Hello everyone, this is Pankaj Chaudhary from cppsecrets.com. Today we are going to discuss regarding STD vector. So in this video we are going to discuss everything about this STD vector. Okay, what is it and why C++ given us STD vector and what is the actual use of STD vector and at which place you need to decide you need to use the vector. Okay. First of all, what is vector? So before going to discuss regarding the vector, first we need to discuss a little bit about array. Okay. As we know that we are having built-in array in C and C++ programming language. So array is something it's continuous memory allocation for the same type of data. Okay, like we are having integer like a integer array, and it stores something like 11, 22, 33, 44 like this. It's a continuous memory allocation. The problem with array is, so it it's having the fixed size. If you are defining array like as a of like an integer a of 10, or you are doing something integer star a is equal to, let's say, new integer 10. In both the cases we are defining, you are giving the size here. Okay, and it's compulsory here. Okay, so at the time at this here we are giving the size. This was one of the major disadvantage with the array, because so before storing the while we are storing the data, we need to define the size. So as we are seeing in the industries and in the live network scenarios, so data is not of the fixed size. Okay, so when we are receiving the data from the network, okay, so that is not of the fixed size. So how people are doing how people are solving this problem with the array is, they are defining the array of large size. Okay, and they are storing data into it. They are first creating creating a proper space, so and then they are storing it. So there is a chance so you are receiving the small amount of data and you are allocating a huge amount of memory. Okay, so this was one of the problem. Okay, so here I am going to discuss one thing. First of all, let's say there is a problem here. Let's say you are receiving some data from the network. Okay, like as 1, 2, 3 something. So the size of data is not fixed. Okay, so you can receive the 2 bytes, you can receive the 4 bytes, you can receive the 8 bytes, or its size is basically not fixed, and you are going to store this data into any of the data structure. So if I will say you need to implement the array for this requirement, how you are going to achieve it? So in this case, the best method is you are going to allocate the array of some fixed size. Okay, you are going to allocate some fixed size. Okay, like you start from some fixed value like x. Okay, now after x, if you receive more bytes, then you need to do the realloc here. Realloc. Okay, so realloc, that means allocate more memory. Allocate more memory. Okay, so there are two methods here. Okay, so two methods. One is you are going to add some value to this x, or you just need to multiply some x by some value. Okay, you can increase x in this way. Okay, so if you do some R&D, or you can see the big Wikipedia, the optimized method is, so you are not going to add the value, you need to multiply it. This is the correct way. Okay, I will come to this point. I will explain this problem also, because if you are having you have taken some 100 bytes base size. Okay, so that means when you are solving this problem, you have created an array of 100 bytes. Okay, so when you are storing it and it reached to the 100 bytes. So after that, if you taken some extra space of 10 bytes, okay, then 10, then again it will this space also fill up, then again you will take 10 bytes, then 10 bytes, okay, like this. So this is quite complex, because here you are having 100 bytes and you are adding more and more bytes, 10 bytes here, okay. The problem in this part, because when you are increasing memory here by using the reallocate, okay, so what it is doing that it is first allocating memory of 110 bytes, okay, then copying this 100 bytes here, okay, and then start copying your bytes from here. This is the 100 position, 99, that's is from the, if it will start from 0 to 9, so 0 to 99 and it will start from here. So every time, because this is a behavior here, and again you are doing the 100 bytes, then again you are doing copying the 110 bytes. So this type of things are not possible. So there is one solution. So let's say instead of 10 we can use 1000 bytes, okay. So 1000 is again a problem, because if you get the less number of data, then you are allocating more bytes, okay. So the when C++ engineers working on this, so they thought like as we need to use the implementation factor. So instead of doing this, we need to implement x, okay. So let's say if I will choose some base value like as 100, okay. So if our space memory will fill up, then we are going to multiply this by y. Let's say y is equal to here is equal to 2 something. So our memory will be 200 bytes. Then after 200, that means 400. After 200 it will be 400, then 800, something like this, okay, like this. This is quite good approach, because in this approach when we receive the 200 bytes like as here, so that means we are having 200 bytes, that means we are receiving more amount of data. Now we need to create a more space. Instead of doing the allocating 5 bytes like this, we need to just double it, okay. And it will again one more advantage here, that when it is doing the relocation, it will not relocate every time, because we have created a huge space before. Not like as just you have multiplied it by 2, okay. So this is something we are saying it as in computer science theorem, computer science we are saying it as a k factor concept, k factor concept, okay. So in this the reason of explaining this, because because we are discussing the vector, but here we just go through the little bit about this another algorithm method. So this method we need to implement to resolve this, to solve this problem, okay. So this is nothing, this is the dynamic memory, dynamic array something, okay. We are it's dynamic, not dynamic array, it's something array which is increasing the size at runtime, at runtime. So this type of array, which I explained just now here using the malloc and reloc method. So for this type of requirement, this is the one of the best approach, okay. This type of array is nothing, it is a vector. For this requirement, C++ engineers develop the vector, okay. This is vector. So now you understood that what is the array, and what is the actual use of vector over the array. So vector is something which is increasing their memory at runtime, okay. And we are aware from the k factor concept, okay. Now we are going to discuss this. The vector is like an array only. It is having continuous memory allocation. Let's say this is a vector, okay. It stores 11, 22, 33, something, 44, 55, okay. This is the vector. Now I'm writing one small program, and then we will actually draw how the vector will allocate, how it will go into the memory, and how this complete mechanism is working, okay. And we will discuss regarding the capacity, vector relocation, pushback, all the things we are going to discuss here. Okay. So first of all the STL containers is template base. Okay, this template base. Okay. So when we are discussing the vector is actually a class. If you see the C++ code, you can find that there is a program vector.c, and inside this is the class vector. Okay, this is the class, and this class is a template base. Okay, so this is a template based program. That means when you are defining the vector, you need to provide the data type. Okay, so for which data type template is going to open. Okay, so let's say this is a vector. I have created std colon vector. So for using this vector, you need to include the vector header file hash include vector.h. Okay, this is the header file you need to include. Now this is the std colon vector. So as I already explained that vector is the template class. Okay, so here I am creating the object of the vector class, nothing. Vector is template based, so here you must need to provide the data type. Let's say I have created integer. Okay, then v. Okay, so this is the v is the object of the vector class. Okay, and we have templated it for the integer. Okay, so what this will do, this will just create a v here, because v is the object, so it definitely place in memory somewhere. Okay, this is the v vector. Okay, nothing else. So here I have not inserted any element till now. So this is just a v, and it's having some size. Okay, this is the v. Just that's it. Okay. Now, okay. So when this v will allocate, there is just few concepts which came. So because this is the vector class, so it's having some public method, some private method. Okay. So there is a few public method which is very important in the vector. The first is the size. So when you are going to allocate this memory, this vector, after writing this line, you can print like this. Okay, cout v dot size. Okay, you can print like this. Okay, there is another concept with the vector, that is a capacity. You can print this also. Okay. Now coming to this, this is the vector. If you print this size, so here at this time vector size will be 0, vector capacity will be 0. Okay, this time. Okay, so because it is not having any element till now. Now I am going to insert some element in this vector. I have written push underscore back. Okay, I have inserted 1 in the vector. So what is it will do? So this is the vector object. Okay, so it contains some value. So this is the object of the vector. Okay, so when you are inserting it, you are not so is it not inserting like this. Here it will write 1, or here you are going to write 1, not like this, because this is the object. Okay, this is not going to change. Okay, because if you see the class, if you are having a class, okay, inside a class, let's say this is the class test. Okay, and inside a class you are having some integer pointer star p, like this. You have created object of this class test t. What it means? T is the one object here, okay, which is having some memory address like 100. Inside t you are having some variable p, okay, because it's having some integer pointer p. And if p is having some memory, let's say I've written something like I did some new for this. Okay, new for this. So p is pointing to some memory location which is outside this, right? This memory location is pointing through this this p only, but which is outside of this. Okay, here I address is something 200, and I have located something like, let's say 400 bytes here, 500 bytes here. Okay, so like this. Okay, if I am inserting something into the p, like I am writing something inserting into the p some value, so it is going to change here 1, 2, something like this. Okay, it is not going to change 2 3 like this. It is not going to add here 1 2 3. Okay, just clear with this concept. So this is just the object, nothing else. Okay, if you insert 1, so somewhere, because this is the class, it is having a lot of variables. So let's say I'm just representing it dynamically from the diagram. Okay, let's say you have inserted some 1. Okay, so what vector will do, vector will create an array. Okay, like this, some array. Okay, because you have inserted 1, so it will store 1. So when you are inserting something, at the time he is increasing his capacity. So here I am not talking about the size right now, because if you are inserting some data, it is going to increase the capacity. Okay, so capacity was 0, and now and you are inserting something, so capacity will be 1. Okay, because first time it is going to, first it will expand the capacity, then only you are going to insert it. So how vector is working? So when you are inserting some data into the vector, first it will checking for the capacity. If capacity is, if it is having capacity to store the elements, then only it is going to store it. Okay, so when you are inserting this, so before inserting it, what vector is doing, it is going to increase the capacity. Okay, then it stores the 1. Okay, so after this line, if you are, I am going to print this. After this line, size will be 1, capacity will be 1. Okay, clear? Now I inserted another element here. V dot push back, like as 2. Sorry, here 2. Okay, then again capacity is 1, and we are inserted the second element. So what it will do, it will increase the capacity. As I explained in the previous example, it is going to multiply x into y. Okay, so capacity is 1, so it will let's say there is a k factor concept. Okay, k. So what it will do, vector, it will increase the capacity by 1 into k. Okay, let's say I am assuming k is equal to 2 here. Okay, so the capacity will be 2. So capacity will be 2, that means it is having capacity to store 2 elements, and it is having only one element, that is 1, and the space for one element is available, so it is going to store the 2. Now it will add the 2 here. Okay, so before adding it, okay, what it will do, it will do the relocation. So first it will allocate the memory of the 2 elements. Okay, because capacity is 2, it will allocate memory for the 2 elements. Copy this one here, then remove this memory. Clear? Now I have inserted this again. So after this line, size will be 2, capacity will be 2. Okay, now I inserted v dot push back 3. Okay, so in this case, what it will do, the capacity is 2 here, so again 2 into k, which will be 2 into the k factor is 2, so it will allocate a space for the 4, because its capacity is 2 and 2 element already stored here. Okay, the previous 2 is stored, so it is not having, currently it is not having any memory to store the third element. So what it will do, it will increase the capacity, so capacity will multiply the 2. So what it will do, it will allocate the memory for the 4 elements. Okay, it will copy this 1 and 2, remove this 1 and 2 from here. Okay, then insert the 3 here. Now it is having a space for one element again. So after this line, size will be 3, capacity will be 4. Now I inserted v dot push back 4. Okay, so here while inserting the 4, what vector looked at, it's having, the capacity is 4, but it is having only 3 elements, so it is having memory to store the 4th element. So what here, it is not going to do anything with the capacity, because it is having a space to store the more elements. So it will copy this 4. Okay, after this line, size will be 4, capacity will be 4. Now I am going to insert the 5 here. V dot push back 5. So when we are inserting it 5, so again 5, this is the fifth element, but it is having 4 element only, okay, and capacity reached to the maximum one. Now what it will do, it will increase the capacity. So capacity will be, capacity is 4 here, 4 into k, so 4 into 2 is equal to 8. So it will create a space for the 8 memory location, 8 memories, okay, 1 2 3 4 5 6 7 8 something. It will copy this 1 2 3 4, then 5, okay, 6 7, again one space, okay. So it is having more space, it will create more space, okay, here. So after this line, size s will be, size will be 1 2 3 4 5, and capacity will be 8, okay. Now so after this line, if you insert 3 more elements, capacity is not going to change, only size will change, okay. This is the complete concept of capacity and size in vector, okay. This is the k value, k factor, okay. K value is 2 on G++, k value is 1.5 in G in VC++ or Visual Studio, okay. This is the complete understanding about the vector. So vector, how this relocation is going. So this is this method, we are saying this method as a relocation, okay. This is relocation, okay. We are relocating the vector. Apart from this, so here you need to take care, because if you are playing with a vector, you one of the common problem which I have seen in the industry is that in case of vector, iterator is invalidating, okay, in most of the cases, because you are pointing, you are having iterator and somehow your vector is relocated, okay. So in that case your program will crash. So if you are playing with a vector or iterator, you must need to make sure that iterator is always need to be assigned. This is the basically behavior, okay. So vector is providing some APIs like as a reserve. So reserve basically, as we know, we are seeing that this relocation is happening, okay, multiple times, okay. Now if you are sure, like as you are sure that you are going to receive 100 bytes only, okay, 100 integers, okay, here in this case. So in this case, you just need to call the after declaring this vector, you just call the v dot reserve, then pass 100. So it will store the space for the 100 elements, okay. In this case, it will not going to it will not do the relocation up to 100. After that, if you insert the 101 element, then it will do the relocation, okay. Like this, vector is having multiple APIs, functions are available, okay. The one more thing, vector is not having the remove function, okay. The reason is, if vector is a sequential container, okay, if you remove something from here, like from 3, then all the elements after 3 is going to shift, okay. So for this is the time consuming process, because if you remove something, okay, so if you remove by value or something, so it is the time consuming process, all the elements is going to shift, okay, in the vector. So in STL, whatever APIs, whatever functions is providing with the container in STL, that is the provided based on the time, based on the time complexity and performance. So remove, if C++ engineers think that the vector should have the remove function, they can they are having ability to provide this function, but they have not given it, because if they will provide, it is the time consuming one. It's having bad performance. So with the STL, only those APIs is provided which is having the high performance, okay. And in the next video we will see, go through the each and every function of the vector, and we will deeply discuss all the vector vector function, the functions which are available in the vector class, okay, like a reserve, at, erase, lot of functions are there. We will discuss each one by one. So this is the topic. This is the in this video we have deeply discuss the vector concept. Okay, vector. We have here we are not going to discuss the vector. What are all the functions available in the vector. Those things we will discuss in the next topic. Okay, so I hope you enjoyed this video, and your vector concept definitely clear. And this concept, because this is a basic concept which definitely help you, because without knowing these concepts you cannot directly jump to the vector API. That will not help you. You just did it and then you can use it, but your vector concept will not clear. So this is this is the pillar, like you can say something like this. These are the pillars. So to understand the vector or any of the HTML containers, so just you have clear understanding about the container, why this container is implemented, what is the actual design of the any of the container. Then only you can directly, when you start using the vector APIs, what are all functions available in the vector, you can directly visualize those functions, the behavior of those functions. Okay, I hope you enjoying this video, and thanks for watching the video. And please like and share this video, and also do not forget to subscribe our channel cppsecrets.com. Okay, because we are uploading lot of videos on daily basis, so this definitely will help you. Okay, thank you everyone, thanks for watching the video.